Hello everyone, my name is Paul DeWise. I'm a sales engineer here at Forerunner 3D Printing. And today I want to talk with you about why sometimes we recommend letting us honeycomb your parts. So specifically today I have a HP MJF build platform pulled up. Majority of the time, this is the technology that we're going to be recommending we honeycomb your parts for. But there are instances where potentially SLS or maybe even SLA DLP could potentially have the same rationale applied to it. So anyways, so what we have here is we have a whole bunch of nesting blocks that need to be printed. And so what you'll see is we have them kind of nested inside and outside the build platform. I'm going to nest all of them inside the build platform for you. And you'll notice they're not honeycombed. We're looking at the bottom side of the blocks. You can see the top side of the blocks. There's no honeycomb. These are solid. So anyways, so I'm going to run our nesting tool. And the important thing in the world of MJF is build density. So you can see we've got our parts spread basically all the way up to the top of the build. And our current nesting density is 16.93%. So let's call it 17%. So in this case, these are going to be printed in TPU rubber. We cannot go above a 12% nesting density in TPU. If these were going to be getting printed in nylon, we could go up to 17, 18% potentially. So higher, but we're talking TPU for this build. So we're way over what we can get away with. So what that means is basically we have to remove some parts from this build. So I'm just going to slide these off the screen and I'm going to reselect these. I'm going to rerun my Elgo here. And now we're at 12.87, still too high. So let's grab a couple more off the top here. Get those off there. Run the packing algorithm here again. So now we're right at 12%. So that is the very tippy top end of what we can get away with this technology and material. So that means we're going to need to do a second build. So now that puts us into, for this build right here by itself, we're going to be looking at a cost per detail of $131.78. That puts us to a total build cost of $3,689. So that's just for what is on this build right here. We're still going to have to set up another build to print this over here. So we could easily be probably close to $5,000 to get all these parts printed. Now, there is something that we can do to help reduce that cost. So this is the same exact build of parts right here. And what we have done is we have gone through and we have honeycombed all these parts. So I'm actually going to drop back to that other platform and I'm just going to grab a part here. I'm going to show you what I'm talking about. So what we can do is we can come in here and we can select the bottom face. In this case, the bottom face of the part. Your parts could be very different from this. The same rule or the same process kind of applies. We would select a face. We would say honeycomb. We have 3 different types of honeycomb: heavy duty, medium duty, and light duty. We're going to go with medium duty for this. Based on your application, we would help you pick out which one of those makes most sense. Basically, it's just thickening things up or making the kind of cells smaller to make the parts a little more heavy duty. So yeah, so I'm going to kind of adjust my position of my honeycomb here a little bit. And basically, I'm just making sure that I tie these 2 holes into the honeycomb structure. And so we kind of manually align everything, hit OK. I didn't do a perfect job, but I think you get the idea. They would both look like this right here. So anyways, so now what we've done is we have removed a ton of mass out of these parts. And that does a couple things. So when we first started talking about this example, I was talking about cost. And this does greatly reduce cost because we're using less material. We charge you for the material that we actually turn into a part. All the powder that's going to be left in these cells, we can reclaim all of that. We don't charge you for that. But there's also accuracy, and accuracy is improved greatly by doing this. So with MJF specifically, it's a hot process. It's a thermal process. We are melting powder to make these parts. Well, the more powder we melt, the hotter the build gets. The hotter the build gets, the more these parts are going to lose accuracy. They're going to warp, they're going to twist, they're going to move all over the place. And we can get surface finish defects. We can get shrink on the outside of the parts. We call that elephant skin. We can also, the build gets so hot, we can actually get thermal bleed on the outside of the parts, where we actually melt excess material onto the outside surface of the part. So there's a lot of reasons for accuracy, around accuracy, to also want to honeycomb your part. And they're still very strong. We've printed thousands and thousands of parts with honeycomb in them up to this point, and very rarely do we see a failure. If you have a really high load application where your part's going to be seeing a lot of load, let us know. And maybe there is an argument for printing your part solid, but also there's other honeycombing strategies we can do that are stronger than this. And if your part doesn't really see any load at all, let us know that as well, and we can go with a lightweight honeycomb strategy and make the parts even more accurate and cost less. So that's kind of accuracy, and also let us do the honeycombing for you. You saw how quickly it was for me to do that. Don't go into SolidWorks or Creo or UG, whatever CAD software you're using, and try and do all this yourself. It's going to take you forever. We can move so fast through it, we don't even charge extra to do the honeycombing work for you. Plus, we can kind of control how it's done, so we can apply our best practices. So anyways, so now you can see back in my original build that we were talking about here, now I have one honeycomb part. So I'm going to switch over to my other example build. So these are all the same parts we were just looking at, but I've already gone through and honeycombed them and everything like that. And you can see we're at 10.39%. We are well below our 12% threshold. So not only are these parts going to be more accurate, they're also going to cost less, because instead of having to do 2 builds to get you all your parts, we're now going to do 1 build to get you all your parts. So remember, I had mentioned before we were going to be around that $5,000 mark for all the parts if we were going to print them solid. Well, now let me reprice this and we'll see where we end up at. So now our per part cost is $89.65, and our total build cost is $3,585. So we are probably in the neighborhood of close to $2,000 less to build these parts than what it would have cost us to build these. So kind of in conclusion, when we bring up the idea of honeycombing your parts, it can help make the parts more accurate, and it can also help make your parts considerably cheaper. So, feel free to go down into the description under this video. There'll be some more resources you can look at there around honeycombing, and why we do this and why we think it's a good idea. And if you have any further questions, definitely reach out to us here at Forerunner, and we would be happy to answer them.